Howdy.
Working? We're live.
We're live. All right. We're live.
He'll give us a...
We are live.
These are just fish.
Second. Oh, I can hear us.
Test.
Yeah?
Yeah, we can start.
We can start.
We can start? Okay.
All right, we'll be on standby.
Okay. Hello, everyone. Super excited to, and I'm going to essentially present this first Augmentation Lab and Ekkolapto Fireside chat. It's the first one in the series of the Augmentation residency that we're doing. And I'm super excited today to introduce you to Addy from Ekkolapto. Addy founded Ekkolapto, which is a polymath research institute in Florida. And then also we're joined by Professor William Hahn, the director of the Machine Perception and Cognitive Robotics, laboratory, also from the Florida Atlantic University, and they're going to be talking about a couple of really interesting topics. I don't want to spoil it too much, so I'll leave it to them. And I think we can really traverse a lot of intersecting and transdisciplinary domains here. So without further ado, I'm really happy to introduce you guys to these two. I think I forgot to introduce myself, actually.
Yes, you should tell everybody who you are.
Yes, hello, I'm Dunya. I am one of the co-founders of the Augmentation Lab. As hopefully many of you know, we are a transdisciplinary R&D community of philosopher builders who develop technologies to enhance the human condition, and we really want to marry the disciplines of essentially technology development and deep thinking, philosophical thinking, and ethical development of these. So we want to educate people who are not only able to build technologies that exert a lot of power over society, but also build these with a lot of wisdom into how people interact with these technologies. So now, Professor.
Augmentation is lit.
Thank you. So is Ekkolapto.
Thank you.
Thank you so much, Professor William Hahn.
Great, thank you so much.
All right, Dr. Hahn, I want to give a quick intro as to who you are. Where were you born? What's your life story? Where are you going?
I don't know if we have time for all that, but first I just want to say thank you. It's really exciting to see groups like this and what you guys are working on. It's extraordinarily impressive. I got to hear the other night the projects that are developing here, and it's extraordinary. So thank you, and I'm really honored to be joining you guys today.
Yeah, just to give them a quick hint of what you've done, what you work on with your
work. So I've been thinking about computers all my life.
Before any of you were born, and then some.
Thanks. But the first adult word I learned how to spell was install, because if I typed that in the keyboard, the video game would turn on. So I grew up with machines, and I anticipated AI. My little brother's favorite movie was Terminator, and we watched that like on loop. And as I got through school, I remember questioning, where is all this AI that I was kind of promised as a kid? And not only did it not seem to exist in the markets, it wasn't in there in academia. There wasn't, you could take a class on AI, they didn't cover anything interesting. So it was kind of this AI winter, as they call it now, and it was cold. And so now we're in this really exciting kind of AI spring or AI summer, and that's kind of what I want to talk about today, and some of these ideas that I've found in this. Trying to predict the future of AI, I had to go backwards. I had to kind of become a historian, and I was never previously interested in history. But through necessity, I just kind of started going backwards, and I started to find myself, okay, what was AI in the 90s? What was it in the 80s? What was in the 70s? And then I found myself in the 1950s, and then the 1850s, and then the 1750s, and so on. And in that pursuit, I came across a bunch of ideas that I think are unreasonably interesting and completely under-documented in terms of how powerful they could be. And so I kind of wanted to share some of these today, and I think it's in line with your mission of augmenting human intellect and trying to think about what people are going to be in the future.
Wonderful. I think, I guess a good intro for me is I'm also a part of this lab, this long name here, Machine Perception, Cognitive Robotics. And what I'm really interested in is how the heck do you connect everything? What is an idea? What is a mind? what are these fields that we have names for called chemistry, philosophy, biology, all these kinds of things, right? Where do they come from? What type of problem did you have to be solving to come up with the name of, we're going to do this thing called chemistry, right? One of the things I'll get into later in the presentation is how potentially the oldest form of neuroscience and cognitive science and psychology was being a parent and regulating your own mind, you know, of yourself or your child. But a little more about me. I'm Addy. I run this organization called Ekkolapto, which at this point is maybe about a year old. And we go, yes, and it's Ekkolapto TV, right? Ekkolapto TV, you see that? Yeah, Ekkolapto TV, right? And basically, yeah, so I started this thing about last year. With Augmentation Lab, I worked on the first longevity, unconventional computing, and cognitive research hackathon, big jumble of words. We had Stephen Wolfram, David Seclair, Manolis Kellis, Yosha Bach, Kurchai Mungol, lots of heavy hitters in the field, also on very short notice. And then I just recently finished up a polymath salon at UT Austin with Scott Aronson. And I've done many things over there with Dr. Hahn at Florida Atlantic at his lab. We recently hosted this event called Polymath Medical, who some of you were here for. And we also had somebody called Michael Levin, who I'm a giant fan of. A little bit of a stan on Michael Levin, and him as well. But you know, on Michael Levin, and he talked about bioelectricity, cellular intelligence, all these crazy things. And what you're going to hear from me today is a little bit about the problems that I'm trying to solve and how it relates to what he's doing, because I think there's many similarities, striking similarities, which could be a good or bad thing. But I'll let Dr. Hahn take it away now.
Awesome. Thanks, Addy. Yeah, let me just jump in. But I want to make this interactive. I'm kind of like an LLM, that if I'll just sit here and say, what would you like to talk about today? So it'll be best if you guys have questions. This is largely going to be about this unconventional language that I found and I'm fascinated about. But I do research in a lot of different things, from the foundations of computing, artificial life, the nature of consciousness and cognition, and stuff like that. So please jump in along the way and ask me questions. I've been trying to entertain ideas that I might not previously have done, like even just the history itself that I didn't care about. And I really like this quote. Marcus Aurelius says, "The object of life is not to be in the majority, but find yourself in the ranks of the insane." And I think we have to be willing to go a little bit nutty to get to this next level. I like to say that the future is not what we think it is. Because if it was, we could just go there. We could just move in that direction. The reason why the future sort of takes time to get there is we don't know exactly, in this amoeba, you know, sort of search, we don't know exactly which direction it's going to pan out. I've been fascinated by this idea of infohazards, so kind of warning a bit that there's information that can change your brain. And we can get into that more. When I first came across this idea, I was hesitant to even share it. Just the concept of dangerous information kind of scared me a little bit. Not for myself, but I didn't want to do harm by...
The concept of it was an infohazard.
Yeah, the concept of infohazard to me was an infohazard. This is a basilisk. This is an animal from mythology. And the idea was that if you even saw that thing, you were done for. Right? It didn't have to bite you or sting you or anything. Just seeing it would knock you out. And so I'm fascinated by that idea. And for me, this was one of the biggest information hazards from my understanding of technology and history and computers. Does anybody recognize this artifact? Anybody know what this is?
Yeah.
Yeah, what is it?
Well, they technically don't really know, right? They think it was maybe, they found it in a shipwreck.
Yeah, so.
Like it was well beyond its time.
Exactly, so about 100 years ago, some sponge divers went down and they found this, and it was one of the best shipwrecks from antiquity, and had a bunch of sculptures and things like that, statues. And they found this chunk of stuff, and they didn't know what it was, and they ended up doing x-rays, and they still didn't know what it was, and they had to bring in basically a watchmaker. And it wasn't until they brought in someone who actually had real hands-on experience with machinery and dials and gears and stuff like that they were able to piece together what it was. And it turns out it's a computer. It's an analog, mechanical, astronomical computer that's carbon dated to about 2,000 years old. Now, there's no explaining this. This artifact completely disrupts the timeline of Western civilization and technology. We don't see anything like this for like 1800 or maybe even 2,000 years later. And we have to ask, what culture made this? I think artifacts like this aren't the work of a lone genius. There wasn't just some guy you know, sitting alone making this. There was a culture. They went to school. Like, what did they study in kindergarten? What language did they speak? And so on. So I'm fascinated by this. Finding these artifacts, I joke it's like finding an iPad with a Civil War bullet stuck into it or something. It just doesn't add up. And so in this search, I find a lot of things that I thought would belong to the modern world, and they surprise me when I find them in the ancient world, right? So here's a machine, a magnetic cryptographic machine, right? I think of things like cryptography and using magnets to build a machine to process information. I think of that as like the 1940s, like Alan Turing on the scene kind of thing. And then here we have something from the 17th century. How do we account for that? Why didn't I learn about that in school, right? They taught us all this history and they didn't talk about anything interesting. What cultures made this? Where did they go? Did that culture go extinct? Did that turn into what you see here in Cambridge? It's not quite clear. Here's another artifact that's completely outside our understanding, in a sense that if you were just to glance at it, it wouldn't be obvious that it's anything more interesting than it looks like. It looks like a necklace or a skirt of some kind maybe. But it's actually a database. It's an information processing engine and language that they use to run an empire. But when people came and they saw this thing, it was impossible for them to understand how interesting it was. And so maybe in a million years when people find like a thumb drive, they'll be like, oh, whatever, it's a keychain. They wouldn't know what it was. Here's another one that is a diagram of how to get a canoe from island to island in the South Pacific. And if I were to see that kind of thing, I would think it's art. I would have no idea that that is an information map. And then here we have an example of Leibniz's notebook and his introduction of binary numbers. Now imagine looking at that page and being like, oh, social media is going to emerge out of that system. If only we could scale it up. So it's not obvious that that would lead to the future we're in, but it did. Here's an interesting woodcut. It's got this personification of arithmetic, arithmetica. And there's kind of these two schools of thought here, Pythagoras on the right. And you can see that this is kind of the math we learned in school, right? The Arabic numerals, and you draw the line, you put the times table, you carry the one, that whole math that we learned. But there's a whole nother tradition in mathematics that some of you might have learned, and it's the abacus. And it's still used in a lot of places. And especially on the other side of the world, there's kids that are so good at it, they can do it with their hands, in their head, kind of thing. They don't need an actual abacus, and they can compute sums.
There's also savants.
Yeah, exactly.
We'll get into that later.
Yeah, jump in when you want to, Addy.
Yeah.
This is kind of like is where checkers and chess came from. This is like a board game. I like to think of it as, imagine playing Monopoly, but it's real. Right? It actually represents the state of affairs in your business or your empire or whatever it is. And so these people would work around this checkered table and they would move pieces around, and that actually, ran an empire, essentially. And this is from 1177. So this thing that we think of as computer science and algorithm and all stuff like that, or even digital twin that people were talking about last time, that's basically a digital twin for a financial system, right? Here's an arithmetic clock, and this is a calculated clock, but it was also called an organ. And so I'm very interested in the sort of history of computers and musical instruments. When we think of like punch card computing, there was punch card organs long before that. I don't know if has anybody seen this? This is Vannevar Bush's differential analyzer. And so this is what computers looked like in the 30s and 40s. And it operated like a clock. The values were represented by like the angle of the shaft as it rotated around, just like a pocket watch. And this was able to do really sophisticated math problems, differential equations at a time that would take a lot of...
UCLA's cyclotron is its new differential analyzer. This amazing mechanical brain quickly solves mathematical problems that would require months by ordinary computing methods.
What I wanted you to hear in there is they called it the mechanical brain.
The brain is becoming an invaluable aid in our aircraft capital, speeding engineering research and reducing time spent on flight tests.
So this thing just like absolutely changed the world in terms of manufacturing aircraft designs and all kinds of really hard problems that took. It's not even that you had to have a good mathematician to solve those problems, that there's certain problems in differential equations that you have to solve numerically. There's no closed form solution. And so this machine is a big breakthrough. And then that led a few decades later to folks like this, von Neumann and Oppenheimer here.
You mean Cillian Murphy?
Yeah, right. And von Neumann famously said, I'm working on something more important than bombs. He's working on computers. What was really fascinating to me is going look, this was at the Institute for Advanced Study, the Johnny-Act, they called that computer.
Oh, by the way, Ekkolapto might be at Princeton or Institute for Advanced Study in a couple weeks. We'll see how that pans out. It
was designed almost like an engine. It was like a V16. It kind of had like this kind of car engine type design.
Are engines computers?
Well, pause for 1 second, I want to come back to that. But one of the most interesting things I found in looking at this machine was one of the first programs that they ever run, they were looking at digital parasites. And computer programs kind of evolving and taking over the memory space. And I just think that's so interesting for so long ago.
Wait,
Oh, we lost something here, hang on.
Just
Complex
HDMI cable.
UCLA
Oh, the cable?
Yeah.
I might even
new differential.
Oh, there we go.
There we go.
that was me.
Yeah, so you said, is an engine a computer? Well, that's something that I really want to kind of think about and discuss, is whatever a computer is, right, in that bubble of things, I would like to place motorcycles and cellos in that same bucket, right? I think we need to generalize how we think about machines. But with the engine side, we need to think about power. Right now, computers run on 18 volts or something like that, or your phone even less. Imagine a computer that ran at gigawatts, right? Like a power plant, but a CPU kind of at the same time, right? If we want to imagine the technology that would power like a starship like we see in the science fiction films, we would need things like that, things that are doing what we now call computing, but we also think of as like power generation at a massive scale. And what does that even mean? And then things with like the cello, we need to think about analog, we need to think about dynamical systems, we need to think about materials that are instantiating that process. This is one of my favorite graphs. It's been described as the most important graph ever graphed. And there's lots of versions of, I'll show a few versions in this talk. This is Hans Moravec. This is back in 1998. And he predicted, based on this Moore's law, where if we extrapolate this trend, the suggestion was by the time we get to the 2020s, we should be able to simulate lizards, mice, monkeys, and ultimately people. And I would argue that we're there now. And what's really interesting is it got faster than we thought. So like this is the 1965 trend, and that wasn't, it was faster than that even, than the best guess. So about a decade and a half ago, labs started to build these things where you could get GPUs and you could make this kind of cortical simulation, and that led to this LLMs and AI that we have now. I think we saw that one. This I think is interesting in that I'm worried that humans have a sort of a blind sight. Our ability to predict the future can often be drastically wrong. And in this show from the 1960s, they kind of famously invent the flip phone. Well, this show was supposed to be set 300 years into our future, but the first cell phone call was only 3 years later. So that's off by a factor of 100. And so I hear a lot of people that are skeptical about AI or other technologies like bio and quantum and space and all kinds of cool stuff. It's like, these things will get here faster than we imagine. The saying is that we overestimate the next 5 years, but we underestimate the next 15. Another example, in the 1980s, we see this sort of mechanical walking thing, and this is also supposed to be, well, a long time ago, but in some sort of future compared to our technological state. Well, it turns out,
ago in a galaxy far, far away.
Exactly. But it turns out General Electric had built a walking truck in 1965. The movie doesn't seem quite as original at that point. Why is it we don't know about that? Right? Why did I have to discover this only a few years later when I'd been looking at the history of technology? And pull hands, anybody ever seen this thing?
No.
Why? It's interesting, right? So that's what the kind of this talk is about, is like ideas that are really interesting that why don't they show up more? Yeah.
There you go.
Yeah, I think one of the most interesting ideas it's a crime that this isn't a major, right? That you can't get a degree in cybernetics just doesn't make any sense to me, especially now. One of the founders said it's like the biggest deal in the last 2,000 years, and I think he might be right. I also think subjects like this, I call them victims of their own success. They essentially got classified. This is how you steer what's called a gun director for anti-aircraft and things like that, going back 100 years to steer cannons, and that naturally is not public knowledge. Let me know when you want to jump in, otherwise I'll just keep going.
I'm waiting for something. Keep going.
Okay.
I'm going to do something at the end. Keep going.
Has anybody read Snow Crash?
Yes.
Yeah. Awesome book, isn't it? I highly recommend it to everybody. And in this book, there's this idea of an information hazard. There's a signal, there's a pattern that if people see in particular programmers, because they know binary and they're susceptible to these patterns, that this will disrupt your thinking and will actually crash the human being, right? Like you crash a computer. And so the story is about the propagation of this virus. And they're saying, is it like a drug? Is it like a virus? Is it like a religion? And they say, what's the difference?
The information is prompt engineering mind.
Yeah. So this is one of the things that led me into this kind of dangerous information idea. And when this story first came out, I thought it was a really clever plot thing, but I thought it was completely ridiculous. The idea that there would be a visual pattern that would disrupt your brain just seemed like nonsense to me. Didn't fit with anything I knew about the visual stream and brains and all that kind of stuff. But it turns out that when we build artificial brains and artificial visual systems, they are precisely vulnerable to that kind of pattern, and that we can make static-looking images that will crash the machine. And if these were designed as models of our brain, as our brain susceptible to something like it. In like a mild case, it would be marketing. In an extreme case, it would be like mind control, Manchurian candidate kind of stuff. In terms of like robotics and computer vision, these are patterns that you can add to the stop sign that will completely disrupt the computer vision system. Now, we wouldn't be confused about what that is, but you can get the AI to think that's everything from a 45-mile-an-hour speed limit to a person.
I do want to add one thing on the topic of how this relates to coordination of cognitive systems, which is a fancy way of saying mind control. And really what you're sort of saying is, like right now, we're not going to do it obviously, just prepping, but let's just say I say fire. Right? If I say it with a certain tone of voice, just that noise, just the physical noise alone is going to make the whole thing go haywire, and all I did was make a noise. Right? And it's really interesting that there's that kind of level between the observer and the observed that carries that kind of weight, where I just have to make a noise and now the whole thing goes haywire. Right? And then also it's, there's other things you can say to people that would kind of trigger that. And it's the idea that, it's basically the idea that language and perception is a way of, we're programming each other's minds right now when we're talking to each other, right? You don't have to pay attention to me right now. Why pay attention here? I'm talking to you. I'm making these noises, these gestures, whatever, but why are you even paying attention here? Why not something else, right? What is it that directs goals and sets behaviors in diverse cognitive systems, whether it's something like this or something like this or bugs on the ground or whatever, right? And I think we're going to get more into how these different modes of perception and cognition will start to connect as Dr. Hahn goes on.
Exactly. So that means that language is kind of this double-edged sword. It's like connecting your computer to the internet. You can do thousands of things, millions of things you couldn't do before, but you're vulnerable to, like Addy said, you can put ideas directly in your head. I can make you think about something essentially without your permission, right? The best you could do is up and leave, because I don't want to hear any more, but as soon as I've said it, you've already heard it effectively. And that can be extended to this idea of adversarial reprogramming. So not only can you get the machines to be confused. I like to think about it as like when you're driving in the car and there's like a bright glare and like the sun is like so bright, you're like, I can't see a thing. It's kind of like that. For the AI, this is like glaring and just throws off the rest of it. We don't see it that way. So you can extend this where you can actually reprogram the neural network to do a completely unrelated task that it was trained for. And you don't have to update any of its weights or change any of the parameters or anything like that. And it works for, you could attack multiple architectures. So like it's not even architecture dependent. But what you do is, say you have a neural network. The example I like to give is you run like an animal nonprofit and you put out a wildlife camera that can tell if there's an endangered species on the trail. And because you have funding as a nonprofit, you put this API out for free. And you say, anybody who wants to look for endangered species, feel free to use our compute engine. We'll pay the cloud credits. Well, maybe I run a casino and I want to count cards or count dice. So what I'm going to do is I'm going to hijack your API and I'm going to take this counting problem here, sort of looking at like a dice type thing, and I'd say that's a 4 or whatever. Now, what I can do is I'll map 4. If there's 4 squares, I want you to say tiger shark. And if there's 5 squares, say hammerhead.
And if it's 8 squares,
yeah. So the important thing to remember is that this neural network the only thing it can answer is the name of an animal. That's like the only output it has. You can't do anything else. It doesn't know anything about counting. You've never trained it to do this counting task. But by making this carefully crafted mask, which works across different models, and embedding your problem inside that, this thing will think that's an animal, it will give it one of these categories, and then you can go back and get your answer out.
You know what this reminds me of? This idea we've talked about perceptual cryptography, right? Think of optical illusions, audio illusions, right? I'm sure some of you have heard of this green needle brainstorm audio illusion thing. It's the little Ben 10 watch and it's playing this noise. Now, again, the noise is the same. The noise has not changed as far as I know, right? But what's happening? The observer, the mind, is hearing green needle or brainstorm or some mix of that depending on what you're walking into. That audio is the same. Now imagine if you're in some situation where you want to send a message to one observer, one mind, one person, and not to the other, right? You'll send out somewhat of an ambiguous signal, that one person will interpret one way and the other person will interpret it in a different way, right? Now you have to also think about how this applies to things in biology, right? So when you're taking in this information, which we'd say is calories, nutrients, all these things, it's information, is that you don't want it all doing the same thing to every organ. They're supposed to be interpreting the same proteins and everything differently, right, in order to build this thing that we call a body. But the brain, you don't necessarily want things happening in the brain to happen in the liver, right? So it's this idea that cryptography is really just about what the observer is interpreting and seeing. And in fact, the logo of Ekkolapto is the Necker cube. This thing, if anybody on stream, it's literally, it's this cube. Now the cube is really interesting because, it's this It's a sort of 2D shape on a piece of paper, right? But depending on how you look at it, it's looking at, is it facing this way, upside down, inside out? But that's happening in your mind. That, that square has stayed the same, right? And in fact, if you really try, you can forget that you're looking at a cube at all, and you'll see like a little rectangle with a diamond around it, right? But that's there on the paper, on the screen. That's not technically wrong. But
And not only is it perceptually ambiguous, it's perceptually unstable.
Yeah.
That when you see one, you will just sort of dynamically switch to the other representation, and kind of go back and forth. So if we're trying to communicate to other humans, to machines, to the far future, how do we know we're not sending this kind of perceptually ambiguous message?
Well, there's benefits in ambiguity, which we'll get into later. Yeah.
So here's just some examples of that. So I like this idea they call the Goldilocks effect, right? Where the porridge is not too hot, not too cold. It shows up in astronomy and cosmology, the idea that if our planet was a little bit closer, we would burn up. If we were too far away, it would be too cold. And it turns out there's also the similar effect in psychology, that we are all trying to represent the world. But we don't need to make it overly complicated. I don't need to model electrons to know what I'm going to say next in this talk. But I don't want to just assume that you guys are not there or whatever. So we have this middle ground complexity where I have to model you as minds. We have to think about what we're going to be working on and so on. An example I like to give is like a dog, right? A dog doesn't get upset about stock market prices or global politics or anything like that. It lives in its reality, and it's on an evolutionary timescale. It's constructed a brain to create a dog reality that's very useful to a dog. But that means we're blind to sort of what's actually out there, and that our mind is just designed so that we can operate as a human being. So that got me thinking about like the different modalities that are in our mind. And there's a classic idea from what's now called folk psychology of left brain versus right brain. And a lot of neuroscientists unfortunately kind of threw this out, and they're like, oh, it can't be that way. And I don't think it's necessarily cleanly split across the left and right hemisphere. Obviously, the two hemispheres communicate with most individuals. But there does seem to be almost two entities inside us that look at the world very, very differently. And one of them is sort of logical and rational, and it likes small numbers of very strong inferences. If this, then that, then this, right? And it works by sort of reducing the problem to the minimal parts and then looking at that. So it's kind of an analysis, right? It's a reduction. The other side does the opposite. It's sort of a synthesis engine, and it likes more information. And when I think about a problem like recognizing a face, and so there's no set of instructions I can write down in English or any language that will say, if you follow this, you will get a decision tree that says this is Addy's face. You can't do that, right? There's no one piece of you that makes it your face. It's a high dimensional. There's a lot of very weak inferences. And I think this is kind of the two different sides of this. You want to jump in?
That's fine.
Okay. There's another story I'd like to recommend that's kind of related to Snow Crash. It's called Babel 17. And it's about a poet who is approached to try to break a military code. And she comes back and she realizes it's not a code, it's an entire language. And so she tries to learn this language, and in doing so, it dramatically changes how she thinks and her ability to think very quickly, very complicated situations in very concise, precise ways. But in doing so, learning this language corrupts your mind. It installs a self-contained schizoid personality in your mind alongside the other.
Would you call this a kind of thought form almost?
Oh yeah, well, it's more like a thought. It's like more like a whole entire organism that's stable, and it ends up that she becomes a saboteur, right? That this signal from the enemy turns you in, converts you, kind of thing, conscription to the other side. A fantastic story. And then there's another book that these are sort of all these themes of lethal text, lethal concepts, where the characters in these stories are disrupted by information they come across. And the other one that I think is very relevant, great story, is called Macroscope. And I think this is what AI is giving us, right? Science, had these very nonlinear transitions when we got the microscope and the telescope, right? It just changed the whole universe in terms of how we thought about our place in it and what everything was all about. And I think that AI is building us a macroscope. It's allowing us to see the big picture in a way we've never seen before. But I'm cautious that big picture is scary at a minimum, and it might be dangerous in some sense. Like the dog would just get stressed about things that don't matter. Thinking about the entire world all at once will just make you nutty. And so in this story, they create this object that can see over massive distances and spaces, and it drives people insane when they look through it.
You mind? I have one other book in mind.
Oh, please, yeah.
It was Fred Hoyle, Black Cloud. Fred Hoyle.
I have a copy.
It's a nice good book.
Yeah, distributed consciousness.
Yes, a cloud, thinking cloud, started to communicate with one of the humans. Results haven't been good for this human.
Exactly, right? So I like to say, if you see the face of God, it'll be the last thing you ever see, right? So same kind of thing. So this is the story of the Tower of Babel, that we were sort of building this understanding that challenged the authorities, let's just say. One of my favorite information hazards is this idea from the Middle Ages, and it was called the dancing plague. And this was a spontaneous group behavior that's not well understood. And people basically started dancing, and they didn't stop for weeks on end. And multiple people died from exhaustion. And you have to wonder, like, how good was that, how catchy was that tune, right? Would you want to hear that song, right? It's like in Homer when he puts the wax in his ears and has the he puts the wax in the sailor's ears.
Earworm.
Yeah, exactly. But it's a lethal earworm. It's a song so compelling you will dance to death just with that. Are we subject to group behaviors like that today? I think a lot of people would worry that we are. And then in that research, I came across some really interesting stuff that's terribly confusing because there's sort of layers of obfuscation over the decades where people took this secret knowledge from, as empires change and cultures change and the dominant religion changes, people have to take older ideas and mask them as something else once they don't get murdered or they can just survive in this new framework. But there's this oddly interesting overlap between tarantulas and music as medicine and these dancing plagues, and I'm trying to parse them all out. At this point, there's sort of a bucket of ideas. I'm trying to see how they're all related. But the idea of music as medicine is something really fascinating to me. And so this other story, which is actually one of Gulliver's, it's in that sort of that same theme. This is a Hungarian artist. He's the one in a different work, he coined the term robot. But this is a fantastic story about machine intelligence, about finding kind of an alien species that's mechanical in nature. This is from the 1930s. And they communicate with each other in a musical language. And that musical language is called Soul Ray Soul. So we'll talk a lot about that. But it says, how miraculous the effect of music, as if someone pounded on the door of our soul from the outside. And when we think about like piano music can stir your emotions and English prose can put ideas in your head, why can't we do the same both at the same time? I want to be able to think in music. I want to be able to remember in music. I get earworms. I get radio songs stuck in my head. Songs I don't like. I know the lyrics to thousands of songs I don't like. Right? They were without my permission. And so I'm just in the supermarket trying to get things and I'm hearing this sort of stuff go into my brain. Maybe that's more nefarious than we think. We tend to think, oh, that's just how reality works. We listen to the music in the supermarket. It's like, well, but what is it? So who's read Isaac Asimov? Right, the Foundation series. Do you remember The Mule and the musical, the Visisonar? It actually shows up in Futurama in a few of the episodes. But it was this musical instrument that was able to control people's emotions. And so I went out searching for that. And the only thing I could find is the Encyclopedia of Imaginary Technology or something. And I thought, well, why wouldn't we have a piano that plays colors? And it turns out I found one, also this one from the 18th century. And it was a piano. This is like a caricature of it much later. It was not the actual device. And they call it the ocular harpsichord. But they say this color music was like the lost language of paradise, right? This sort of Eden thing, this pre-Babel type language. And it doesn't make any sense to me that I can't buy one of those on Amazon, right? And now I do see, like in the store, you do see pianos that have colored keys and all that. And I look at them based on what I know now, and I say, the colors are all wrong. There's something not right about it. So we'll see what that looks like. So in finding that, I came across this language called Soul Ray Soul, and that means language in this language. And it's a very sort of synesthetic, multimodal language, in that words can be represented as sort of musical phrases. They can be written out as numbers. They can be put out as sort of this Latin-y kind of thing. And so it's made out of the solfege, the do, re, mi. And then we have different ways we can represent it. So we can kind of write it out like a Latin alphabet. We can write it out like you're drawing music. It also has this fantastically alien-looking glyph script that you can encode the messages in. You can write it as just numbers. And then you can do sort of a sign language with it, right? And so I'm trying to learn this language. I'm still at the stage of learning the alphabet for the language, essentially, because I have hopes that it can help me think differently. And so this is kind of an experiment, a thought experiment. And I'd say I've had success in that already. That when I see that red cup, I'm like, oh, that's dough, right? And when I actually extended this, I think of them as flavors now myself. So here's what some of these words look like in this language in the glyph form. We were talking earlier with some folks about the movie Arrival, and this is very similar in that there's a language, and that learning this language fundamentally changes how you think. And in this case, in a very powerful way, that the character is able to think meaningfully about the future in ways that we can't do in the same way. So here's an example of this. We could say, I speak sol, re, sol, so that would be do, re, do, mi, la, do, sol, re, sol. Or we could just say 1, 2, 1, 3, 6, 1, 5, 2, 5. Or we could just write out the colored squares, or we could do the hand gestures, and so on. And so here's some example of what that text might look like. Then I came across this electric piano, essentially. Question?
Who invented sol, re, sol?
His name is Sudre, Francois Sudre, and he was in the 1830s, and he basically worked by himself. Oh. He was trying to get a commission from the French military because there was hopes that you could use like a bugle to talk across a mountain and send messages. And so he'd elaborate, we'll show the dictionary in a minute, so he developed this language for that purpose. In the public record, it didn't take off, but I'm curious if maybe it was used somewhere else, or I tend to think of this as a kind of an example of something that might be much more powerful. This is kind of like a crack in the door to think, well, what would a musical language look like? And can I think in music in a technical way? Could I write a computer program? Remind me at the end, because my long-term goal is to write a computer language that looks like this. But this is an electric piano from 1759. What? It doesn't make any sense to me. I thought electric pianos were from 1959. And so there's this weird history that I don't know why we didn't learn about it in school, because it's just so interesting. Here's a mechanical water organ from the Roman Empire, and you would have helpers kind of pump this thing up to do hydraulic pressure, and then it was like a player piano. You could set the tunes over here, and the drum would go around, and it would play this thing automatically. And so when I see things like this, they seem really rich, right? We tend to have this terrible notion that the people in the past were just simple, and they were just struggling to survive, and so on. But that's not the case at all. And I think if you gave me a lot of money in a 3D printer, I don't think I could make artifacts like this in any short amount of time. This looks like a database to me. This looks like NumPy, right? This reminds me of like PyTorch. You have this very organized kind of matrix, nested matrices that form a tensor, and this very rich language. And I don't think this is just kind of like elevator music at the party. It strikes me as too rich. There were problems in the world that they needed to solve, and they would spend so much time and energy on something like this, to me suggests it was something much richer than entertainment. This is a musical alphabet for steganography, explicitly to disguise a message as music. And again, this is hundreds of years old. Musical cryptography. So this is a form of the psychedelic cryptography, because if you're not in the same mental state, the same cognitive framework, you would not perceive this.
Qualia Research Institute also works.
Exactly, yeah, QRI. So here's another stenographic thing. This strikes me as looking awful lot like a modern neural network. And that led me to some interesting ideas. Language of the birds, the music of the spheres, things, again, that science kind of kicked out a few 100 years ago or so. And I think we need to bring some of these ideas back into the fold if we want to understand things that's happening. So this overall kind of thing where I tried to look at, is the brain a computer-like object? And the nature of computers is that you program them. So if we are a computer-like object, then we would have something like programming. And what would a programming language for a human being look like? What properties would it have? And I think just from first principles, it would kind of have to be everywhere. It would have to be very old. It couldn't be anything new. It would have to be very relevant in the modern world. People who knew how to do this programming would be very successful. They have monetary wealth. We would use technology to do it. We would use old technology. We would use new technology. It would have the ability to change your mental state. It would have the ability to induce emotions. It would have to do the emotions and motions. It would get you to physically move, and all three of those without your permission. And if you look at all of those properties, all those check boxes, music checks every one of those boxes, right? It can nearly make you cry without your permission. You see a concert, you have thousands of people moving in unison, apparently without their permission, so to speak. They're doing it, they're compelled, like the dancing.
Synchronization, coordination.
They're synchronized. We have it in the radio, we have it in our cars, we have it in the background. The people who control music it's worth a lot of money. It's one of the largest industries and so on.
A good analogy of the music thing is you can have many music devices called metronomes, and if you clock them at different rates and you put them on, a shared table, eventually they will start to sync up. And a concert is very similar to that, but it's happening the same. I think it's the same phenomena fundamentally that's happening, but it's being expressed in a different way through this thing that we call language and all of that.
Exactly. So I think, would we recognize it though? Would it be like one of these information hazard type things where it's outside of our conception and our perception that we wouldn't see it, right?
Do you think that's why musicians and like pop stars are so loved and famous and admired?
Kind of. Well, it's consistent with the idea that they're playing a very important role in like crafting society, and I think unconsciously we know that. We all kind of admire them and wish we could be like, wow, that's so cool. I was talking last time I was here with some folks about, I suspect that in the ancient world, imagine like when the concept of music got developed, right? Like the word music. Well, it would have been older than that. So go before the concept, right? And now people that are famous throughout history where people were listening to them, what if they were kind of the first rock stars? What if they were speaking in a rhythm and a cadence?
Caveman Elvis.
Yes, and other people, if you didn't have any concept of music or pop star, you would just be like, this is really compelling. You wouldn't know why you were really drawn to that, but you would just think it's really neat. And I suspect that might be what had happened in a sense. And maybe they're playing that role now, and the interesting thing is, do they know it? And I would suspect they don't.
I mean, I think it's funny that we literally call people influencers, right?
Right. And so in researching this thing, I tried to figure out like what are the technical aspects? Can we use this for a computer interface? Can we use this to induce synesthesia? Can we use this to augment my intellect in a non-trivial way? And can we use it to talk to machines? And so this is related to this idea, they call this the Sapir-Whorf hypothesis, as we've talked about a bunch now, that learning a new language fundamentally rewires your brain and changes how you think. It doesn't just install new software, it can install new hardware effectively. So I have a website for this we could take a look at, and that allows you to put in words in English. Let me just show that real quick, since we're here. So you can find this at solraysol.xyz. If anybody want to help, so you can help me build this out. You can actually plug in a MIDI keyboard and do some cool stuff with the piano. It has like a game up here where you can play the keys on the thing, and so you can kind of play like a guessing game to try to learn this. We have kind of the alphabet up top here. So this is kind of the base alphabet. And then down here we can put in English. Let's just put in, hello, I speak language.
You speak what you're writing in.
Yes. And so then it'll come back and it'll say, okay, that's si, mi, do, re, do, mi, la, do, sol, re, sol. And notice that each word is like a bucket. There's no synonyms, right? Everything is like a concept bubble, and you put all this in there. So I and me and myself are all the same. There's no distinction between gender or anything like that. It operates at a higher level. And so now if I click show in dictionary, it'll take that and load it up here, and I can see there's that sentence and all these different representations. So we can think of it as a string of numbers. We can think of it as these blocks of colors. We can have this
representations of each other almost.
Yeah, these are all equivalent representations. And the idea that I'm excited about is if we learn these and learn to map between them, like what utility does that give us in our ability to think? We can see there's the hand gestures to represent that. There would be sort of the musical score. And then here would be the glyphs, they're not disconnected, and then we can play this sound. Well, that's kind of a dry rendering. I have it slow on here so we can kind of hear it. But imagine if you're really skilled with the piano, you could like put that into another more interesting musical phrase where it would be maybe clear what part was the entertainment and what part was the content. And I think that would be something really neat to do. Okay, let's go back to here. The other interesting property of this language that drew me to it is that it's organized in a way that natural languages aren't. And so in English, we can approximately pronounce words we've never seen before. We can parse out the syllables and go through it that way. In Sol Re Sol, you can approximately define a word you've never seen before. If you parse out the syllables, it makes a decision tree, and the words are organized by concept. So words that start in the key of do are physical and moral aspects of humanity. Things that start with soul are about arts and sciences and so on. So there's this really fascinating structure to this. That's sort of just the same idea. So you could very quickly see what category of idea your word was about. And then it has another property. I like the word reversogram, but there's another one, Smortalap, which is always hard for me to remember and say. But that's the word palindrome backwards. And a reversogram is like a word, when you reverse it, you get another word. But in Soul Ray Soul, when you reverse the word, you get the opposite.
Oh, on the reversograms thing, quick thing. Has anybody ever tried to watch a movie or a television show backwards? Like reverse the thing and watch it? It's like what Christopher Nolan tried to do with Tenet, but they're both timelines are interacting. You can also do this with songs. And it's interesting about how you can build up the same qualia of the song that you're listening to, which can be very visceral and vivid at times, by listening to it backwards and trying to get the same thing. Technically, the information is there. You're just trying to extract it out of it in a different way.
Yeah, but sequence matters.
We'll get to that.
Yeah. But this sort of really interesting property, and I was just saying yesterday, this character shows up too often.
Yes, I know that.
Yeah. Here's some sample text. You can see what that might look like. You want to hear a recording of it? Let's hear it. Let's see if this plays.
Si, re, mi, sol, re, do, re, fa, mi, do, re, mi, sol, la, re, fa, mi, sol, do, ti, la, re, fa, si, do, fa, mi, do, si.
So it kind of sounds like a Latin, Italian kind of a thing. I think that's probably the least interesting representation of it, right? It's all the others that are interesting. There's just some more representations of it. Here's the dictionary. Let me just pull that up real quick so you can see what this looks like. This is what drives the website. And you can see the words are broken down. So do is easy because it sounds like no.
Zoom in.
Oh, yeah.
See if you can.
Do is easy because it sounds like no. Si is easy because that's just the Spanish word for yes anyway. And then other like very common words like and are reserved for these one-syllable ones. And then when we get the binary combinations, we can start to see like you, yourself, he, she, it, them, self, oneself, and so on. And then as we get higher into these things, we get sort of more interesting languages. There's a lot of religious language in here because it's, I think, from the 19th century. And there's a lot of military and kind of trade language because he was trying to sell it to the French military. There's a lot of open spaces in this language. It's a very small language. There's maybe a few thousand words in it, but there's plenty of space in this sort of the scheme to add new words. So it would be interesting to maybe have a person or an LLM go through and try to.
I have a question.
Yeah, please.
Do you know what he expected the music canon to do?
The musical canons. Yeah, he actually made musical canons.
Yeah, but what did they do?
So he tuned, he tried to build 7 canons tuned to these notes and tried to communicate that way.
As a communicator?
Yes.
Not as a weapon?
No, these would be communication canons.
Okay.
Yeah, and so he tuned 7 of them, and then you would, you know, kind of do it that way. Yeah. Okay, so this is all just more of the same here. You can sort of represent it as on your fingers that way because you can get 7 spots like that. Here's just some examples of this sort of glyph version of it, which when I first saw it seemed like impossible. I was like, oh yeah, forget all about that. But it's actually not that difficult. Like, you can learn how to map this between those 7 characters in like 20 minutes. Like, it's not nearly as difficult.
Why is it that these have the shapes that they do?
I don't know.
Is it the shape that matters, or there's something deeper it's getting at?
I don't know. But these are the questions I'm trying to answer. And what I'm trying to do, I found somebody who put these together. I want to put these in color and so on. I want to have them like I want to build like a real full dictionary that has every representation for every word all in the same spot so we can really see them, kind of thing. So here's Sudre. Yeah, it got some brief excitement from some people about 100 years ago, and then it kind of fell off the map, but I suspect maybe it was used for something else. So here we see like mi sol would be good and well, and then if we just put that backwards, sol mi, that's wrong and evil, right? So we can sort of get this internal consistency, and when we look at things like word vectors with LLMs now, there's sort of these structures that emerge. What sort of structure would emerge from this, and can we use an LLM to make a better version of this? Here's just some more examples of the glyphs. Here's sort of like the first 7, and then the pairs, and then here's would be the triples. And so these will be all the pairs, all the combos of 3, and so on as we go up. I suspect this is weirdly related to this. I'm sure some of you guys have seen this picture before. This also has 7 colors and chakras and things like that. So I suspect this idea of programming the brain and the body and the mind and music, and it's probably more related than we can understand in the West, like, because we don't, it's so difficult to combine ideas like that, because to become a physicist or something, or a psychologist means, okay, not this stuff, right, to first approximation. That's what it means in the modern world, unfortunately. So in this kind of pursuit of dangerous ideas and unthinkable thoughts, it led me to think about mind control, as I said, like in the weak sense of marketing and in the stronger sense of getting you to do things against your will that you're not aware of. And in sort of the same theme of Isaac Asimov's 3 laws of robotics, I tried to come up with the 3 laws of mind control. And the number 1 is you cannot detect a successful psychological attack. You will not know you've been hit. Yeah.
Have you heard of Bij mantras?
I don't think, no.
In Hinduism, each chakra has a sound associated with it. So it'd be interesting to see if there's a...
If they map up.
If they map up, yeah.
Yeah. What's the name of it again?
Bij mantra.
You'll have to spell that for me after.
Okay,
yeah. Thank you. But yeah, it's exactly that. These sort of like frequencies, you see there's apps on the internet that will play them, and they'll claim that each one activates something else. There has to be something to that. I have one.
Hold on, I have to do some more.
Okay. So I suspect there's something interesting there. And why is this not a part of the modern world? Is this just a historical accident of the way science developed, or is there some weird or interesting reason why we don't talk about this in a common way? So the idea that you can't detect a psychological attack, if it misses, if like the punch misses, you can be like, hey, someone tried to trick me. Then you can see the psychological attacks and warfare, but only when it kind of misses. If it lands the hit, you won't know you've been hit. Number 2, if you're not thinking about mind control, you're already under its effects. Right? I think it's something that the simplest way to protect yourself from being tricked is just to know that there's a possibility you might be tricked. Seems kind of straightforward. And then number 3, the only secret is that it works. Everything else is out in the open. You can find patents on it, you can find books on it, you can find documents, historical documents, government documents, all kinds of interesting things that would suggest that the ability to not just like control a human's mind, but really manipulate psychology and to think of psychology and mind as software, interesting things like that are surprisingly out there, but there's just this meta concept of, that's not real. I wrote a science fiction story about this. You can find this at Lethal Text AI. This is a science fiction short story. It only takes 5 minutes or so to read, but it's kind of related to this idea of the LLMs exposing. I believe that this macroscope idea, these AIs, they're going to present us with uncomfortable truths and inconvenient truths that we're not ready to deal with, and how are we going to parse them out? And I think we'll have the tendency to say, oh, it's just hallucinating. Where do we draw that line, and when do we say that? Yeah, and then I think I really like this quote that we kind of need to bring everybody into the future. That getting to where we want to go, it's not just going to be one type of intellect or one type of person. We have to bring everything all together, and I think that's how we'll get to the future. So yeah, please. I'm just going to stop there. So
I'm curious, who do you think is the best mind controller at the moment, or some examples, of people who are good at
the social media companies, right? So like doom scrolling, it's going to get worse because the algorithms are going to get really, really good at like gluing you to that platform, and there's going to be
by design in a sense. And
there's going to be sort of dangerous feedback loops with that. I came across a sort of disturbing post that someone put on a message thread online, and they were talking about these sort of virtual relationships that are emerging, where people are building sometimes romantic relationships with this virtual character. And people on there, these are people who are using it, kind of talking to their own community, and they said, are we using this thing because we're lonely, or are we lonely because we're using this thing? And they talked about a kind of a feedback loop that very quickly their ability to socialize in real life and to deal with real humans was just like evaporating, that they didn't have the patience for it. Human relationships are difficult. Communication is difficult. And when you have this virtual partner that's just absolutely perfect and, whatever, regular humans kind of seem difficult. And the same thing with these like social media scrolling, it'll get to the point where you're like, well, outside's kind of interesting, but this is interesting. And I think this is dangerous. Yeah.
What do you think we can do to counteract that?
Raise awareness. I think trying to have like disconnect times. I love the idea of like
build a cognitive
social environments. It doesn't have to be like a bar or whatever, but places that don't have TVs, places where you leave your phone at the front door. I'm trying to develop a habit. I'm not good at it yet, but I recently got like a phone holder to like put in the kitchen, like in the 90s, right? That maybe you guys wouldn't remember, but some of you would, right? There was a time when a phone was a place. It was not a person. You called a location, and you hoped that person was relatively near that location. And now you call people. You're like, I'm gonna call that person. So I think that disconnect. I joke with people that I think within 10 years or so, people who have the means will move to the country and tell their kids they're Amish. They won't necessarily have to become Amish, but they'll be like, oh, we don't do that. Or maybe some sort of like non-religious Sabbath thing where they say, you know what, on Friday nights, we're not going to do technology tonight. I think we're going to need that, and I think that's going to help us with mental health and all kinds of other problems.
Do you feel like we might need to become better mental hijackers than the people at the social media companies to
Yeah, that's a great
fight
question.
them?
Yeah, we kind of need to like program each other for good. We need to be aware of this, that we are programming our friends, we are programming ourselves. And a lot of things that, when we think about, what do they call it? When you kind of just like talk to yourself, it's like self-help, and you put guideposts, or you say, I'm going to manifest this, or I'm going to put a vision board of where I want to be. I think science would have ignored that. Even psychologists, I think, kind of ignored that. But now when we look at language models, you can prompt them. So can you prompt yourself? Can you prompt yourself to become a better person? Right? How you talk to yourself really matters. How we talk to each other really matters. And when we look at the models, like just a few tokens can completely disrail what they're doing. And I think we're all subject to that vulnerability. And so I think we need to be aware of like the responsibility we have to ourselves and the people around us to be mindful of like what tokens we're putting out, what ones we're letting in our mind, and just being aware of it, I think, is the best thing. Yeah.
Cool. Quick question regarding the idea of being able to kind of like add information to someone. You've talked a little bit in terms of this on the mind control front, but what in terms of something that's a bit more constructive? For example, like education, where like if you're learning a subject, you can just learn all of the information about that subject, or learn how do you mention like the abacus if you're able to go ahead and learn how to do that mental model instantly.
Right, 100%. And I think this is why I want to learn the musical language, because I think it'll give us a better ability to kind of install positive ideas in other people. I'm sure you all, I have professors that I had over the years, or people that you know, and they installed a small copy of them in your mind. Right? You have small copies of your friends and family that run in your mind, in a sense. And so thinking about how we actively in education kind of do that process, and how we convey information, how we get science to the next generation, and so on, I think this is all very related.
Okay, cool. Does anybody have we'll take questions for both of us together afterwards, but does anybody have a question for Dr. Hahn right now? Any interesting questions? Go for it.
You said the first law is that if you were under a psychological attack, you would not know.
You would not know that you've been hit, yeah.
You're pretty aware of the social media and what the damaging effects.
Yes, you can be aware of like that there's a war happening, right? But when I'm doom scrolling for an hour, am I really aware that like I'm caught in that? Kind of. I had to set a reminder on my phone to like tell me to have like this external message. But I think you're right in a sense.
What do you think of financial markets as a form of mind control? We don't often think of the price signal controlling our mind, but
well, that's that leads to a whole like discussion of. I think markets are intelligent. I think they're a kind of organism. I call these things hyperorganisms. And these are things like life forms that are made out of people. They aren't people, but they're made out of people. And like the classic examples would be corporations, this organization, sports teams, religious groups, things like that, where if you were to pluck out any one of the members, the engine would continue. And if we think of like large multinational corporations,
but you can't necessarily do that with the literal engine at times.
Right. So that's why it's a better kind of software and technology. Lewis Mumford said that most of the machines that people have built throughout history have had human beings as the moving parts. Bureaucracies, governments, societies, and things. These are like virtual machines that are running algorithmic type processes, but it's the people that are the CPU, in a sense. And I think the markets are a hyperorganism like that, or it might even be kind of the neuronal pathways of the global brain, in a sense, right? So I have a strong take. I call AGI artificial Gaia intelligence. I think the whole planet is intelligent. I think the whole planet should be thought of as a life form. It might be in an early phase of its developmental history, right? If I were to look at you in the womb at 2 months old, we would assume, oh, it's not really an intelligent being. It's just sort of a cybernetic system feedback loop. Well, is the Earth growing up? Is it in the birthing process, right? Do we want to? Is there any utility of thinking about like a living thing? And if we do think of it like a thing, like the black cloud and such, the markets and, dare I say, capital would be kind of this weird brain. Like if we were to look at the fMRI of the planet, you would look at how money and influence and information moves around. And we see that, right? We look at telegraph networks to Wi-Fi in the last 200 years, and so we absolutely are building a nervous system for the planet. And at the same time, we now have Amazon, which is like a circulatory system. We can distribute these little cargo packages all over the planet. We're taking all of the energy, from different systems and putting them together and making kind of these large, complex supply chain loops and stuff. That's exactly what it looks like when biology starts, right? That's what sort of proto-life and proto-cells look like.
So drawing upon that analogy of just forming of this hyperorganism, currently the computer systems and the engines have mostly enabled us to do things faster and spread out faster. With the AI agents, it seems more like we're going to be having new forms of cells and interfacing with them. So right now the hyperorganisms are composed of human beings.
Right.
But soon enough, you're going to have
100%.
Non-humans.
Yes, non-human hyperorganisms, essentially, yeah.
And how do you think that, would that cause like an immune response within the hyperorganism, or would you?
Definitely. I'm optimistic that we'll have sort of hybrid systems that will build hyperorganisms that have a mixture of agents and humans in them. And I don't think that will be too difficult to do. We kind of have that now. So I think we need to kind of maintain that approach. But I think one of the ways to survive these what's interesting about the hyperorganisms, in a sense, it's not that they don't care about people, it's that they can't care about people. They're not humans. They don't have the minds like we have. They don't have consciousness like we have. They don't have empathy like we have. And so when we try to think like, does the government care about me? Does this company who's feeding me care about me? Does the car company care about me? They can't. They're not people, right? People have things called feelings and caring, and abstract, things don't necessarily have that. Maybe they will when we add LLMs in the mix. Maybe we could give a sense of internal morality to the McDonald's corporation, but what would they do? Close down? So they're fundamentally incompatible with what they're doing now, essentially.
These hierarchies of structures, though, do have to have there's ones that are more connected to sort of being more empathetic, and ones that are not just by design, but out of necessity in order to function and be the thing that they are, to not have the empathy. Or it's sort of like detaching yourself from an emotional situation to see it differently.
Yeah, that's interesting. One of the things I've been thinking about is sort of survive, because I think largely the singularity is like the change of these hyperorganisms, in a sense. That it's no longer just like a company that has a legal team that's doing this. It's this very rapid, real-time kind of response, right? Like if you piss off the Starbucks corporation, they'll bring a lawsuit to you or whatever, right? But imagine like all that kind of stuff happens in real time. I think we're kind of seeing that. I think one of the things that people are going to need to do is align themselves with existing hyperorganisms. And whether these are organizations like you're building here, universities that have already been around for 300 years, Ekkolapto, religious things, where there's already hyperorganisms on the planet that are thousands of years old. Another interesting and scary idea is that the AI is going to resurrect previously extinct hyperorganisms that might have been in a coma, or so to speak, right? Whether those are ancient religions or something like that. It has the ability to revive them in ways that could be kind of dangerous or helpful.
So there's this book that I recently read called Thinking in Systems, and the author uses the example of a slinky, and that like the slinky, it moves in the way because of the behavior that's latent within the slinky itself. What do you think are some properties and behaviors that are latent right now in these organisms? Because you said that they don't have feelings, and understandably so. But what are some behaviors? Because I think saying that they don't have any,
which is not exactly true, right? There's organizations out there that have big hearts, and they are abstractions, and they really do care as an abstraction, right?
So like, how can we move towards, like, what are some properties that we can in fact like move the dials on to have organizations or hyperorganisms that are more empathetic?
Yeah, it's a great question. It reminds me of the study they did where, as you know, corporations have a legal status as persons, right, in the United States. And so they did a psychology experiment, and they said, well, if they're people, let's give them a psych test and evaluate them and see what kind of person they are. And it turns out they're psychopaths. And so maybe what we need to do is be sort of monitoring and appreciating that these hyperorganisms are, maybe they didn't have a mind-like object in the 70s, let's say, but they are going to have mind-like objects soon. And we need to think about the mental health of large-scale organizations and take responsibility for making sure that they're happy, healthy, hyperorganisms, whatever that might mean.
Trippy?
Interesting.
Oh, trippy.
What do you think of the age of hyperorganisms? Because there was this talk by an MIT professor that I was listening to that most companies have a lifespan, much like human beings, and much like human beings, the young companies want to be old, and the old companies want to be young. And
that lifespan is shrinking with companies too.
Yeah.
If you go back 100 years, a successful company could expect to be around 50, 60 years, and now like a successful tech company is kind of obsolete in 10, 15 years.
Why do you think that is? Can we have bigger hyperorganisms that live longer?
Yeah, and I think that's how you get, but you have to be careful not to create like a galactic empire or something like that, right?
Why not?
Or maybe that's what you want.
All right, and with that, we will we'll get to more questions afterwards. I just want to run through mine real quick, but give it up for Dr. Hahn.
Thank you all.
And where can we find you online? Which places?
You can find the MPCR lab online. We're at Florida Atlantic University. We're in the Center for Complex Systems. You can find me on my YouTube channel, William Edward Hahn, and I've got a lot of content on there that's similar to these kinds of things.
Yeah, and also he's been featured on one of the biggest philosophy and science podcasts in the world, Theories of Everything by Kurt Jaimungal, multiple times on various different topics, some of which he spoke about today. You'll be able to find all this online if you kind of look up his name. He's also been featured extensively on my channel, the Ekkolapto channel. But yes, let's move on.
Yeah.
What I'm gonna do, actually,
you want me to pull something over here?
I'm gonna go to my Substack.
Yeah, there you go.
Just type in Ekkolapto.
Wait, Ekkolapto has a Substack?
Yeah. All right, we live? Shit, half the audience cleared out. All right. Can language induce altered states of consciousness? I've talked with several of you about this. I might be a little crazy, I might not be, or I might be right and I might be crazy. It's dependable. It's also very funny. I only realized this after the fact, but I published this on 420. That was not intentional, but it happened to be meant to be. I'm going to give you a quick thing here. So, can language induce altered states? Yes, it depends on your definitions of what, that was my fault, of what language and consciousness are. The TLDR, learning unconventional languages, like a language made of smells, olfaction, can probably modify your sense of self, interpretation of memories, and perception in general. Basically, you're using language to induce an altered state of consciousness. So this is also similar to what Dr. Hahn was talking about with solar soul and all that. So I'm just going to kind of go through this. So a lot of this stuff started off with a thought experiment I had when I was very young. And it was a weird one, but it was on, what if I was a dog? Not if I was a furry, not like that. Maybe they have something to say about this type of stuff, but what if I was a dog, right? And then how would I communicate with other dogs? So, the phenomenology of being a dog. And so, how would I perceive things? How would I even construct my thoughts or abstractions or ways of modeling the world? And I realized, if one of the ways that dogs are interacting with the world is through this thing that we call smell, olfaction, right? Our noses, or taste, or all these kinds of things. Is it possible that the qualia and the phenomenology of the way they come up with ideas is in terms of that sensory modality, right? Because remember, a lot of us are biased because we take in information a lot through hearing and through visions a lot, right? I mean, this is visual language. Language is irrespective of this medium. There's something else outside of this that's language, but this is the way that we're expressing these things, right? And formatting it. And I would think about, what are words to dogs? Well, it's not going to be English. It might be smells. When they leave, piss trails on the ground, they do whatever. They sniff each other's tails and their butts or whatever. They're communicating with each other. They're coordinating with each other. And so I would wonder, I wonder if dogs, because of that kind of dominance of that sensory modality, do they have some kind of olfactory language, so a smell language, right? So yeah, I'm really interested in figuring out the unknown unknowns of reality, the blind spots that we don't even know we have. Ironically, the way we think about things like blind spots and concepts in general is probably because of the types of observers and minds that we are. All right, so this isn't just that, we're just human minds. It's that there's a sort of structure of a mind itself that is sort of inherently limited. Right, it's like, if any of you have heard the blind men and the elephant story, right? So remember, in order to sort of see something, you have to see the constraints and the lines and the boundaries. You can't actually technically see the whole thing. You see it in parts and then you stitch it together, right? When you see your hand or an object for the first time, it's only until you stitch together this thing called continuity between these different angles that you actually know, oh wait, I'm talking about my hand or I'm talking about this cup, right? Symmetry has something to do with that. So, we think of math in the way that we do because of the types of observers that we are. We think of music, right? Physics, language, and life the way that we do because our capacities and qualities as a perceiver with the mind that we have, right? All right, what you see is what you get. I have a thing I use a lot. What you see is what you get. If you measure an object in inches, you'll know the object in inches. I'm struggling to not make jokes here. But which types of observers are measuring calipers? I'm not going to grow up, by the way, just so you guys know. I'm not growing up. But which types of observers or measuring calipers are other cognitive systems, dogs and cats, squids and ants, right? So think about this for a moment, a bit of a thought experiment. How would you actually know the properties of this thing without necessarily looking at it and describing it that way? One of the ways that we try to formalize what an object is better is with these things that we call rulers. Right? Now, a ruler is not going to necessarily work in the way we want it to if all the lines are not equally divided. It becomes a much more complicated thing, right? So, okay, I can come up with this idea. Again, where does the idea of a ruler even come from? Who thought about the concept of a ruler and this way of measuring things, right? Where did that kind of emerge from? But let's just say I have a ruler. Pretend these things have equivalent, equally divided lines, and I can measure this table here, and that's fine for that. But now, what if this was curved? Can I have a ruler that simultaneously measures multiple objects at the same time and tries to formalize it? How do you have a ruler that can measure this? It can measure different kinds of curves and extend from 2 dimensions into 3 dimensions. How do you have something that measures moving objects? Let's not just say, okay, now I'm measuring a straight line, now a curve, some other kind of curve, but also I want to measure something that's moving. And as you grow in that complexity and those kinds of dynamics, you start to have something that almost starts to look like intelligence or a mind. Right? So dogs use smell or olfaction and taste quite a bit. It's possible that if those are their preferred ways of interacting with their environment and communicating with other agents, perhaps it would be more efficient for them to directly model their world in terms of those common sensory modalities. This may also be the case for many humans. Now, it's kind of interesting that most of the ways that we communicate with each other, it sounds kind of dumb, but it's in the ways that we can receive it. Right? If we were like dogs or cats, maybe we would be, we'd be communicating and expressing language and thought in the form of olfaction, right? But it's not these words and these symbols. That's not what it is. There's something else that's kind of pointing to and directing yourself to, right? Yeah, so perhaps the reason we tend to think in visuals, words, sounds, or certain representations of an idea is because that's also the main way we communicate with conspecifics, which is kind of the point I was getting at. Most humans have an easier time inputting and outputting information that is visual or auditory based off of our physiological limitations, which is why it would be easier to directly think and model in that format rather than having to make an extra transformation between those, which may take more time and energy. So here's a good example, right? How many of you are artists in here? There's quite a few. Self-identifying artists. We're all artists at the end of the day. Imagine you are an artist, such as yourself, and you want to draw an apple on a white canvas. If you think of and represent that apple as a sound, a motion, or a tactile sensation and try to draw it out on the canvas, it will take time and effort to convert that into what it should look like on the canvas. All right? But if you directly think of the apple in the medium that you'd express or communicate it in, then there's much less work needed to make that conversion, right? So if I'm already thinking of what the apple looks like on a white piece of paper, it's much easier for me to go and transfer that to the piece of paper in front of me. But now if I want to communicate this to somebody in a different language, that becomes a significantly more challenging thing. And there's also the thing that you need to know what language and medium that they're even thinking and communicating in, right? So because distance from the end output representation leads to degrees of freedom for interpretation and abstraction. So if you want to make highly abstract transformations, it may actually be better to think of the apple on the white canvas in terms of sounds or emotion. So here's another really good example. Is abstraction is basically you're kind of at least temporarily removing context. And the example I give a lot, somewhat obsessively now, is Lego. I'm sure many of you have played with and or currently build Lego, maybe obsessively, right? This is Augmentation Lab, we probably have, right? And so what do you do if you have a Lego set? You have you have a Millennium Falcon Lego set. How would you induce plasticity into that system? How would you get it to change? Well, if all the pieces are blocked and chunked together, you're not going to be able to do that. Well, what do? Well, you have to break it. You have to take it apart. You have to induce negative space into it, in a sense. And you're doing this temporarily. So when you're thinking of an idea creatively and you're trying to reconstruct it in different ways, that's exactly what you're doing. You're kind of picking it apart in different ways and combining them in different ways and creating these things. We'll see which sounds go together, which colors go together. It's this whole sort of experimental combinatorics process. But now the interesting thing with the Lego example is how do you actually take it apart and break it down? Well, you could throw it on the ground. That'll probably, get some pieces up, but you might dent and scratch it. You might even break some pieces, right? Especially if these are more delicate things. Another way you could do it that would be sort of a more lossless way of inducing plasticity is by just having a specific tool that can remove the pieces so that they can be put back. You're not inducing any damage or loss of information, right? And you just do that by using your fingers or the Lego tool to pick it up, right? But this is also what's happening here with these representations and abstractions, right? If you sort of train yourself to think of things in a more abstracted way, you're removing context, you're literally removing the structure from something so that you can go and remix it in different ways, right? A sort of good example to this as well is, well, actually, I'll get to that a little bit later with this. Here we go. I'll leave you with a fun question. Let's say you need to cook a delicious Michelin star-worthy dish, but you have no taste or mouth. Okay. That's a lousy life. I need to grow up. I was going to make a joke. Having a good sense of taste and texture with your mouth would make this pretty easy, but there's an added limitation that now forms a different kind of observer. All right, so assuming the same goal remains, you'll now have to interface using a different sensory modality, maybe audition. Using only your hearing, how can you still construct an equally delicious Michelin star-worthy dish for your customer and communicate the instructions for this to another chef with or without your observer limitations? Okay, I have a challenge for everybody in Augmentation Lab today. I want you to, cover your mouth and your nose, and I want you to cook a dish somewhat blindly. Can you construct something that means something to a certain observer, a certain mind, a certain receiver, in an optimal way without actually knowing what they're talking about? For instance, an LLM doesn't necessarily have to know what taste is like to give you a good recipe for a dish. I know many people in the Ekkolapto salons have talked about this, some of which are actually here today. But also this is, well, our colleague Alon Berenholtz talks about this. I'll have to plug him later on, but this is a very interesting thing. It's that there is this sort of nature that you can do things without necessarily knowing exactly what's going on, right? So another example to this is, if you drive a car. I love cars, all right? I love driving cars. But if I drive an automatic car or whatever, all I really have to do is I push the button these days. I have 2 pedals, brake and accelerator, and I use the steering wheel. I don't have to know what the engine is doing, what the tires are doing. I don't have to know any of the intricate complexity of that engine or the structure of the chassis and the transmission to work the car. But here's the interesting thing, is how do you get to know more of a system? You have to induce a kind of stress. I actually borrow this principle from something called hormesis in biology, which maybe we can get to another time. I think these things are all kind of connected. But in order to get to know a system more, you have to stress test it. And stress testing it is like you're trying to measure it in a weird way, right? You wouldn't necessarily have to know much about how your tires work and your rims work unless you have to go and change a tire. Right? It's also like you're not going to necessarily have to know much about your computer to use it until a problem arises. And I also think this relates to this big thing that people talk about with agency and intelligence, whether it's Michael Levin's stuff with the TAME framework or whatever, is I think this is part of the process of where these things called goals emerge from. What actually is a goal and direction? All right, here's a big one. Language is coordination. What you see is what you get. This also applies to the concept of language and coordination itself. The pressures and limitations that create the observer, so observation in general, also creates the kind of language or coordination system that allows communication between observers or perceivers. Let's say you're going to rerun the evolution, of life on Earth, okay? You may eventually land on something human-like, or maybe even, identical humans. But would English form in the exact same way? What about Japanese or the Khoisan, if I pronounce the right language?
This would be convergent evolution.
Yes.
But in thought
And
space.
this also ties into the idea, I think it was William James that kind of coined this, but intelligence is the ability to get to the same goal by different means. Are there certain sort of, base conditions, the least amount of information to get something done that are kind of invariant? That, even if things were to start again, yeah, you wouldn't get English, you wouldn't necessarily get humans, but it trends towards somewhere, right? It's like, you may not want something to happen, but it's still going to happen anyways, right? And this is actually something, I guess, philosophers will talk about this, but this is also something that's been talked about throughout human history, because if you think about, before we had modern technology or anything that resembled a cellular signal or a cell phone or whatever, how would people coordinate with each other when they're traveling thousands of miles away by boat, by walking, by caravan, whatever, right? There's something else that's coordinating a system when it has less constraints. I say that you can learn a lot about a mind, a person, an organism, by what they do with less constraints and information. And I think this also ties into morals and ethics, which we can get into another time, about what do people do when they think they're not being watched and observed. But anyway, so if you had a group of humans who only had taste and smell as their way of interacting with each other and the world around them, note these limitations, what type of coordination system would we utilize? The same idea is also very applicable to agency and cognition at all scales, from planets to cells to chemicals, more on this, in the future. The big picture idea is that by expanding the doors of perception, we can open ourselves up to entirely new ways of experiencing reality, and the things we tend to hold as pretty concrete. Here's a little question to kind of think about here. What is the minimum amount of actual observation or perception needed to generate something substantial or meaningful? All right, so we have this thing we talked about a lot earlier. I think a couple of people brought up about education training data. I think all these things about how can we train AI? What types of training data are there? That's what education is for humans. These are what we hopefully say is beneficial information. It's providing structure, context, and constraints for an ambiguous system to gain more structure and things. This also goes to the idea of the idea of efficiency is about making more from less. And there's many ways you can train systems to potentially be more efficient with what they take from a system. And I actually think one of the reasons that there are these forms of intermittent deprivation, whether it's fasting and calorie restriction in humans, sleep deprivation, which seems to have some potential uses for things, even things like Sabbath, right, or abstinence, or all these kinds of things. Is there are these constant practices of you're taking context away from the system to see how it does on its own without that context and that information and that constraint. And I think it's trying to get the system to learn how to make more with less. Like, one of the things that will happen when have any of you ever tried sensory deprivation before? Maybe raise your hand if you have. Some capacity, right? Now, one of the things you may notice when you do this is that if you really do this for a while and you come back, everything just pops out at you way more. You're almost nearly overwhelmed. And you know, that stuff was all still there. That didn't change. You could walk into the same room, but there's something in your mind, the cognitive system and structure of your mind, that's now become more receptive to that. And all you did was just take it away for a bit. It's like, you know, you don't know what you have until it's gone. I think these are all very intricately tied. All right, now here are the crazier things. Generating altered states with weird languages. I was interested in being able to think of and perceive information in entirely different ways in order to escape from my limitations as a specific kind of observer. In a sense, I wanted to be able to induce altered states of consciousness and cognition without having to take a typical substance or go to sleep or enter a dream. In dreams and psychedelic states, if you haven't already experienced something similar, you will find many stories of people describing their sense of self or attention or some idea or feeling as literally being water or color or time, right? So there's things that'll happen on psychedelic trips. You're like, I am the rock, I am the universe, I am time, I am this object, I became this plant, this animal, whatever. And what's actually happening cognitively? If we were to look at this very, very mathematically in an extremely rigorous way, what actually is this that's happening, right? So one of the ways I first thought of getting this effect was with what I was talking about earlier, the olfactory language, the smell language. So language that uses smell rather than visual, auditory, or tactile information. Now, before I get to some of the last parts here, right, is how many of you have heard of this thing called synesthesia? Raise your hand. Okay? Okay. How many of you have it? Raise your hand. Synesthesia. Debatable.
What kind?
Well, mostly from audio to visuals, especially if you are on a trip, then it becomes, when you are tripping.
When you're tripping.
Yeah, audio to visuals is strong.
But do you have it in baseline? Like right now? Synesthesia?
Not strong, but probably I just don't notice it enough.
Mm-hmm. Well, I suspect we all might have forms of it. We just don't have any way of noticing it.
I was just gonna say, congratulations, you're all wrong. Everybody has synesthesia. If you have language, you have thought, you have perception, you have a form of synesthesia. What is synesthesia? Oh, colors have shapes, colors have numbers, emotions have sounds, all these different things, okay, right? Those are just associations. They're bindings between these different things to create something that we call structure or meaning, right? Again, there's nothing in these letters that actually means these things. This is only trained to the observer. Right? I could say all of this talking in shapes. I'm doing it right now by making noises out of my mouth. Right? I'm doing that right now. Right? This could be Chinese, this could be Sanskrit, this could be whatever, this could be anything. I could completely make up a brand new conlang or something like that to get this point across. The point is that the structure of perception and language itself, it's not in that medium. It's in the observer. Right? Little kooky take, but we'll get more into that. But the biggest point is that you're associating visual information with noise and meaning. That's also when you're saying you're associating shapes with sounds, right? Which is a kind of synesthesia that people will have. This is also what Solar Soul is also doing.
Which I want to mention, as we saw with the sort of 7 colors, I extended those to flavors. I kind of have like a taste synesthesia. So to me, it's obvious that the red is cherry and that the orange is orange and that the yellow is lemon and so on. So I kind of extended it that way.
Right. So I'll tell you a bit of it, I like to experiment a lot and take some risks this way, which are hopefully calculated. Yes, so I like to experiment quite a bit. I'm a biohacker and a bit of a cognitive hacker in the same way. Again, if any of you have been for the previous Ekkolapto events, salons, all these things, I'll ramble on for hours about this. But one of the ways I thought of doing this when I was pretty young is, this olfactory language. And what I did is I started off by using liquid scents to make shapes like letters. So it could be on a piece of paper. You can, go steal your parents' colognes and perfumes, or if you have one, whatever, put it into a dropper bottle or a syringe and try to make like smell shapes. Right, like literally use that to make shapes. If anybody has it, we can even try it today, right? We can do that. And those are like letters, or like, if you're doing the Raven's progressive matrix test things, those types of blocks, all sorts of different ways because you're just representing things. The symbols are basically arbitrary in a sense, right? So I'd be making all these different kinds of smell shapes. Now I would read these left to right and actively associate each smell with either another smell or another idea, a word, visual, etc. Just like you're learning a new language, right? So when we're learning a new language, you're associating this visual information with a sound or a meaning and all these kinds of things, right? So, but eventually these perceptual associations will start to stick, and you can start rereading past ideas and memories under a new interpretation, sort of like how you would update past concepts and beliefs. So how many of you have ever learned, outside of your native language, you've learned a new language? Okay, lots of you. How many of you have tried to go and think of your previous experiences in the other language in your newer language? Describe the thoughts that you had in your old language now in your new language. What's that process like?
Isn't it just like when you switch the context window?
Sure.
Like you're always trying to figure out, like in the beginning stages of learning a new language, like how would you say in the new language?
Yeah.
But I think what he might be asking is take like a childhood memory for which you only had one of these languages, and then try to interpret those emotional states and mental states in the other language. Is that kind of what you're...
Yeah, like, have you ever thought of, something happened in your life, and then you get new information later on, and you're like, oh, now I know what that meant. I didn't get that joke before or whatever, right? I didn't get that signal that person was giving off or whatever. You didn't pick up on those things because you didn't have the language, the interface to receive and pick up on it, right? So this goes into the superior worth thing, which is a little controversial, but, it's sort of this idea that to sort of describe something, you have to have a way to describe it, right? This is blue, this is red, this is green. How can you describe something if your interface is ambiguous and you can't say what it is? I can't necessarily tell you that this is a camera or this is a laptop if I don't have a way of coordinating that and putting that into your mind, right? And so the idea with this is that language very much does affect the way that we think and we perceive things. Now, I don't know how many of you have gotten into the crazier side of this, but you can actually sort of get yourself, by telling yourself to think this is a different color, you can kind of do that. And that's because there is this kind of inherent ambiguity to things like the optical illusion or the auditory illusion that I gave an example of before with Dr. Hahn, where, again, the sound is playing from the Ben 10 watch about the green needle or the brainstorm, but now by keeping that concept in your head, you're now seeing that. It's like the idea that if you have a hammer, everything looks like a nail. You sort of... I'll be expanding on this a bit more.
Interesting experience that I had was I always spoke in Hindi before, but then I learned English over time. And with Hindi, it's very natural to me, and I don't have any sense of like what I'm saying.
Yeah.
Like it's very natural.
Yeah.
But with English, because it was learned, I have developed this secondary taste. Like sometimes I can literally taste sentences that if I don't like how a certain sentence reads, and then
the emergence.
And then it's like you could rotate the sentence in a way, and then it tastes better. It's very hard to explain, like how that happens and why that happens. But that does not happen in Hindi, for example. That only happens in English.
Now, what happens if it was a different kind of language entirely? Maybe you learn Mandarin, or you learn, the African click language, or slower soul. Then what would happen?
I'm not so sure. I would say though that when I was learning English, a lot of the phrases initially didn't make a lot of sense to me. And exactly why are those phrases phrased the way they are?
Yeah.
And the more words that I learned, I think like in harmony the words made sense, but it was very interesting, like how they just didn't fit. In terms of the taste.
I think something not reading right. I think something not reading right or rolling off the tongue right also becomes a choice when you get a very strong grasp of the language. Whereas, like, for example, with English, for me, I have multiple ways of saying a sentence, and a certain sentence doesn't sound right to me because I'm so comfortable rephrasing the sentence in another way. So, but whereas when I'm learning Spanish, I only know how to say it one way, and I don't have the choice of it sounding uncomfortable to me or rolling off the tongue wrong, because that's the only way I know how to say it in the moment at the level I am in Spanish,
But that doesn't happen in Hindi, for example. In Hindi, I can say one thing in like 10 different ways.
And they all sound right to you.
Yeah, but in English, like, there's specific shapes that taste better than the others.
Emergent synesthesia.
It reminds me of there's a Steve Jobs interview And somebody
retrospect connecting the dots, is it that one?
No, but there's, I forget the idea that someone presents to him and he like flicks it off like it's icky. Like he literally goes like this with his hands, like unconsciously. And it's like this, it was like kind of a physical synesthesia. He was like, ugh, kind of thing, like as if he had gotten something on him.
Yeah. But I'm going to run through this real quick because there's a really big idea I want to get to at the end. But already, just to kind of give you the context, I equate perception and language and synesthesia with each other. Bold take, but potentially bold take, but we'll get to this. So anyway, yeah, I would learn this olfactory language as a kind of language, and I would try to reinterpret and read and view my previous memories and states of mind through this new language. Like, you know, you got a new lens for a camera kind of thing, right? You're updating things. So with this new perceptual lens, you can go through all this. The first time this happened, it was very weird and felt pretty dissociative, but I aligned it with what I felt in dreams and later on felt during psychedelic experiences. So maybe it is possible to trip balls by learning a language differently, right? Again, ties into the idea that language can induce altered states. Infohazards can very dramatically change a cognitive system, whether it's artificially intelligent, biologically intelligent, whatever. But you know what would happen is basically, it was weird because I would there was this kind of afterglow, far transfer effect after learning this for a bit. And I'd go back and look at my old memories or whatever, and I would start to experience them as smells. Like they still had, the meaning was still kind of there, but the interface was smell. It's like going from black and white to color, right? Or going from, real life video to cartoon, anime, whatever, right? The thing was still there, but there was a different lens to it. And the trippiest one, there was the memories, all these kinds of things, but your sense of self becomes a smell. Right now, again, I think there's a certain way I was trying to do this, maybe potentially even to get an effect like this, but it was very much the first psychedelic experience I had before I ever took a psychedelic or anything like it. And it's just strange. I almost would not even recommend trying it because it might be a little dissociative.
Is it lethal?
It's an info hazard in many ways. It's lethal text, lethal smell. Well, there are other things that are lethal smells, but this is, but yeah, so it's strange, but yeah, my sense of self became a smell. So you know how I was saying earlier before, on dreams and psychedelics, whatever, like I am water, I am time, I'm this, I'm smell. Now here's the crazy thing. Is that when I first kind of had this experience, I was like, wait a minute, if this sense of self that's sort of concrete, like you hold that quite dearly, if that can be very, very strongly changed, then what is it if it can be changed like that? So
software.
Yes, we can get to this maybe another time, but it's the idea that once again there are these blind spots you don't even know you have, the unknown unknowns, unthinkable thoughts, all these things. It's the thing that's not even in your distribution of thought, like what I was telling you the other day, right? But anyway, so you are literally feeling and qualitatively experiencing these things as smells. Very hard to describe if you haven't experienced it before. You may need a different kind of language to work on this. Maybe something called a hyper-language, meta-language. Many different names have come up with. I also noticed pretty quickly that I could, I'd have a better sense of smell and could differentiate smells with finer detail. But that definitely was not nearly, as exciting. But here's some cooler stuff. Can you make a language out of anything? I want you to raise your hand if you think yes. Okay, well then I don't have to sell anybody on anything. All right. So olfactory lang. It's not the main point of this post. In fact, who gives an S word about olfactory lang or olfactory languages? It's getting at something way deeper about agency and intelligence in Qualia itself, right? This was really more about looking differently, experiencing differently the phenomenology of perception and observation in language as a whole. If any of this has any heft behind it, we could study the mind and grow it in some pretty cool ways. I'm always exploring more, so you'll find if anything maybe disproves it. But yeah, so maybe you can make a language out of anything. All right, here's a trippy one. All right, a language that changes time perception. So this is based on our subjective perception of time and how you can use the quality of time perception itself to communicate kind of similar to Tenet or Arrival. So I'm very interested, in coordination systems, synchrony between different systems, how they align with each other in space and in time, okay? And time perception is one of the ways that we do this just in the day. We actually manage our sense of selves, in a sense, with our sense of time, right? And I think some people are very good at like, okay, it's 5 o'clock, and they'll know right when it goes to 5:05 or 5:10. They can pick up on that. Some of us are maybe not as good. These are also skills that are very trainable. We can talk about this.
I just want to mention, because I do that as a fun game. When I wake up in the morning, I try to guess what time it is before I look at the clock. And this morning I thought, it's probably about 8:30, and it was 8:21. And so I find myself unreasonably accurate, and I don't know how I do this, in a sense. I don't know what mechanism I'm tapping into.
I also,
I have a question. So, so I think the entire room agrees that we can create language out of anything. Yes. A more non-trivial question would be, is it possible to create an alphabet that is distributed amongst multiple sensory modalities?
Yes.
Like some in taste, some in smell, some in vision?
I will be talking about this, yes.
All right. I would...
Well, like imagine like a soul ray soul where you switch the representation inside each word.
Yeah.
Right? Like you sing the first part, and then the rest is like a color.
Yeah.
Something like that.
Okay. Anyways, real quick. So, I'll just kind of go through this since we're running low on time. A language, okay. A language that induces and uses dreams to communicate. This one's a little schizo. This one's a little crazy, but a few things I tried with this one. The more interesting experiment was that if you have awareness during dreams and you associate enough of a symbol or a language with that state, you can induce that dream state even when you're awake. Right? So one of, this has been incredibly useful for thinking abstractly and flexibly about really complex ideas. I actually think the quality of abstracting things in a sober state is actually a borrowing from what happens in dreams and relates to what it actually feels like for an observer to have more neuroplasticity and less perceptual rigidity and more perceptual ambiguity. The benefit of abstracting is that it lets you temporarily step away and remove some components, which then gives you space to rebuild and reinterpret the idea. And then here at the bottom, I'm basically giving that Lego example I gave earlier. But on the dream thing really quickly, right, as if you start to kind of get really good at being extremely aware in the entirety of your sleep and dream cycle, is you'll notice how much more easy it is for you to flip between interpretations of things, remove the context like the Lego pieces and experiment with them much more fluidly. You can change your sense of self into water, all these kinds of things, right? But a lot of that process is also what we do when we say we're having abstract thoughts in a sober, awake state. And I think these are spectrums of cognition and abstraction where in order to make the abstraction, you have to have something sort of more, you have to be tethered to something to even do that, and to then remove away the detail. So one of the reasons that you want sort of your vision and your hearing to be a little bit more tethered is because you can keep that to keep you grounded, but then you can also have the other modality that removes the context so that you can explore and experiment, right? And then, and sort of a social computing, idea of this is, you'll have the people that are doing kind of the work, building things, running things, and then there's sort of the executive abstraction role where it's sort of the job of that entity to go and think of things extremely abstractly, right? Terry Tao, if he was, going and fighting for his life every day in Compton, would not necessarily be able to work on prime numbers. Well, maybe you could do it a little bit. But the point is that you're trying to almost have this distribution between what energy is allocated towards and information is allocated towards. And that's why we have this kind of hierarchy of this more rigid perception that we call vision and hearing and touch, and then this thing that we call abstraction, and why there's a shared qualia between these, and why you can even have an olfactory qualia of ideas, right? That's kind of, the idea with that. I have some other Substacks and things I have, shouted out with this. You'll see Jess on there a couple of times. There's so much more I could talk about, but since we're low on time, let's take some questions. Damn. All right.
What do you think?
Have you spoken to perfumers?
That's Aliade from QRI. Yeah, we've had some good conversations about this.
How did that develop?
Well, something interesting is he already has this sort of idea that smells can induce altered states. If you smell a skunk, that's going to alter your state of cognition very quickly. But also if you smell something very pleasant, it changes your state of mind. And this is the same thing with a very beautiful image, and then something that makes you go, shh, right? It's sort of the same thing. You have a question?
Yeah, I have a question.
Yeah.
So I associate a lot of...
It's going to cut out the signal when you do it. All right, now say it.
I associate a lot of smells with childhood memories, like maybe a perfume my mom was wearing, and if I smell it now, I remember like a party we were at or something like that. And you said that by learning the language of smells, you associate certain smells with your childhood. So if you already have a particular smell associated with a moment, can that switch up if you now learn the language of smells?
I don't know if you always want that to happen, but you can.
So did that happen with you?
Yeah. But what I had tried to do, because I was kind of aware of this thing, and it was difficult, but I also do want to sort of give a little kind of warning to this, because what I've learned throughout this whole thing is that perception and mind is actually staggeringly plastic and flexible, and you don't necessarily always want that. You want control over it, and so it's sort of like, do you always want to, you can get yourself to forget things.
Yeah.
That you ever had an experience. You can have things that you would consider to be very important forms of information and experiences that you can remove by prompt engineering your mind. I say that, meditation and medication are both biological prompt engineering. They're prompt engineering the mind just by saying these things and doing these things.
You're activating networks.
Yeah.
Whether it's gene regulation or biological networks.
But you can override it. Mm-hmm. And I wouldn't necessarily recommend overriding it. I would focus on remembering how it was originally and then almost tacking on something else exterior to that. Sort of like context switching between the language thing. But you don't want to forget it. Because if you focus too much on one thing, you may notice that thing starts to slip away. Mm-hmm. So I have also sort of had issues experimenting with this where there are these things that will slip away, and then I have to figure out how the heck do I recover this back. And I've kind of gotten a way of doing that, but it does go to show that you don't necessarily want your mind to be completely open and receptive and flexible and plastic. You want to have control over that. Mm. And so there's, again, for another time we can talk about how you may actually do that. But just be careful with this.
Are there moments where you've lost something and you don't even recognize you've lost it?
Yep. The thing that you didn't even know you lost.
Yeah.
This is this is a difficult one to figure out. But I think I have some ideas of how this stuff works. Yeah.
I just have a question, like definition basically.
Yeah.
What do you mean by altered state?
Altered state.
In the context of today's.
Do you feel happy?
Sometimes.
Do you feel sad?
Not now. Yeah, well,
so I'm doing a good job. He's feeling happy. Well, your states are kind of always in a level of fluidity and ebbs and flows, right? And an altered state is really the definition I'm giving that is just a state of change in the mind. So whether you're feeling time is going slower or faster, depending on how you're bored or excited, if you're really passionate about something, if you're happy, you're sad, you're confused, you're thinking about something in particular, it's the idea that a state of mind in and of itself is always dealing through these alterations, just like you're measuring an object moving, right? So right now, the expression that you're making is a kind of altered state. There's something that triggered that, right? And one of the ways that we try to use language and mind control and music and all these things is to sort of program each other in a mutually beneficial way, which we have no problem kind of saying that with AI agents, but we also do it with our own minds. So that kind of, we can maybe talk after the presentation.
Right, so like you mean mind, it's like something conscionable or just like a feeling of yourself, like it's ineffable feeling, right?
Those are all altered states of mind.
Okay.
Right? When you're sleeping, that's an altered state of mind. When you're unaware, that's an altered state of mind. Right? Yeah. Any other questions? Yeah.
Yeah. Going back to my previous question, can the alphabet be distributed among different sensory modalities? And then relating to that, when we read too much of a single letter in an alphabet, right? Like the baseline doesn't shift. Mm-hmm. But if you smell too much of something, the qualia changes. Yep. So how are the languages that are olfactory in nature constructed in a way that doesn't cause the qualia to essentially change?
Just real quick, I think it does have it in language, right? You know the effect where you say a word over and over again and it kind of dissolves on you? Mm-hmm. And for me, there's like a switch. As soon as you're able to hear the word, the meaning's gone. Yeah. Right? You can't really do both at the same time. So like the olfaction, I think you can kind of get that saturated to where you're like, what is that word? What am I saying?
So is it the alphabet or the word, though?
I'm thinking more in terms of the word, but
interesting. So would you classify or would you compare the smells to words instead of alphabet?
Yeah, in a sense.
Okay.
It's that you could use it as either or, but I guess sort of in the way we're talking about it now, it would be more like kind of the words in that sense, right? Because, you know, it's sort of like at one point when you start to see a word, you don't even necessarily see the letters as much anymore as you're just, it's like, have you ever looked at those pages that have scrambled letters, but you can still read it, right? This also goes back to about getting more from less information. You can take away information and scramble it, but you can still understand what it's talking about. But you can do that with smell, with vision, with hearing, with touch, with all sorts of different things, right? Okay, we'll do one more. Safal, our special guest.
If I'm gonna try to generalize some of your ideas to non-human agents, so let's say I have like I do some machine learning, right? I can get data from multiple modalities. I can get data from text, images, videos. Olfaction is a little more challenging, but in principle, I think you can do it for that. All the data you learn, you can kind of see the process as extracting information. So there's linguistic information in your sense contained in these, and they're put into like an abstract representation that the machine can then learn and reason with. What do you think of the language of this sort of abstract representation? Is it taking away some of the content contained in the original smells, sights, sounds, and abstracting away something skeletal from it? Is it an entirely new type of language? What do you think is actually happening inside these machine agents? And what do you think this language is?
I love your question, because you always ask good questions. This is why I wanted him to be here. By the way, Oglab should let him present in the future. But anyway, so something I guess the way I'm kind of reading and interpreting your question is, how do you actually get this thing that we call sounds from HDMI?
Right.
Is this in, as Barinholtz would say, in some latent space or platonic space or Ekkoplateau, whatever for Ekkolapto space, whatever, right? Is there some latent space, this kind of limbo, where it's there? It's sort of undefined and unrefined, and then perception is the act of extracting that. Now think about how you build something. When you're ideating and building an object or building a language or whatever, what are you doing? You're actually purposely creating constraints. Right now, if I want to build a cube, right now, there's nothing in the space. It's neutral. The sort of the active mind and perception is you're inducing a constraint. It's a boundary, a line, a Markov blanket, whatever it is, right? I can tell you that this is a cup because of its limitations, right? So one of the earliest thought experiments I've had on this is I would try to think of the simplest thing I could think of as possible. Just super, super, super reduced. And my conclusion at the time, at least, was I would think of, say, a black and white square. And I can know black from white, white from black, but guess what? The only way you'd actually be able to tell those apart is if there's something invariant between them. There's a sameness in the difference, right? This would be the category, the invariance of color or luminosity. And so I guess sort of to answer your question in a sense is that you are tapping into something when you're doing that. You are tapping into something that is otherwise ambiguous, like the Necker Cube logo, the Ekkolapto logo, or the auditory illusions. The active mind is limiting things, right? And the reason that we can tell that there's dimension and complexity to things, it's like the example of a hand, right? Seeing this whole hand at once is not necessarily helpful. You actually want to let it rotate and then stitch together the continuity, right? It's when you have different ideas and things, what do you do to have a bigger, more generalized theory of things? You start to stitch them together and create some continuity. Is that sort of, we'll talk about this more offline, but okay, wrap up?
Just before we wrap up, we do have some comments on the chat.
Nice.
This is Xylid saying that organization of senses from James Gibson, when the senses are considered as active systems, they are classified by modes of activity, not by modes of conscious quality. Another comment is, and within each exploratory system, no exhaustive inventory of perceptions can be expected, since the potential stimulus information is unlimited and the pickup of information has no definite bounds. And last comment again, some of the systems moreover will pick up the same information as others, redundant information, while some will not, and they will cooperate in varying combinations.
Yeah. I guess sort of the way I would want to ask you a couple more questions to that person, but I guess the way that I'm reading this is that in order to have a thing that we call a language, it has to be between not just one mind, but multiple, right? English in isolation, technically you could say when you talk to yourself, we have our own internal languages and things, right? But this thing that we call language, the reason I can talk to all of you right now, tell you to clap, go somewhere, do whatever, is because we all have a shared perception and understanding. It's coordination. yeah, I need to know more about what they're getting at with this, because yeah.
I think for the second comment, the Gibson idea of affordance is very much this Goldilocks property that we talked about earlier. Whereas if you have like a cat and it comes in this room, they're going to look at all the places they can sit.
Yeah.
And sort of the reality that they're constructing that's useful for them will determine what part of that scene they're actually going to take in, because as they mentioned, it's almost unlimited.
Yeah.
And yeah, just to add, they just commented, communication is a mode of activity, question mark.
Communication is a mode of activity.
Yeah.
But I would also say activity, coordination, and language are one and the same thing. Right? We have no problem saying that things across scales, you know, the language of neurons is maybe it's electricity, you know, it's electricity, chemistry, you know, the way different areas of the brain communicate with each other, the way the brain communicates with other organs, even the ways we have BCIs, invasive or non-invasive, whatever. That's a kind of language. There are languages that are biological and electrical and chemical. Right, and I guess, are there any other questions as well, or?
No, that's about it.
I want to end.
That's the question.
Okay.
Yeah.
So when you said your sense of self was a smell, when you said your sense of, how does this thing work?
Yeah, it's good. Just hold it. Just hold it. Yeah.
When you said your sense of self was a smell, what kind of smell was it?
So that's actually a very good question. So my original sense of smell was it didn't have a specific smell. It had the feeling of a smell, right?
Could you smell it? Or did you just know that it was?
It was a smell.
But you couldn't.
But now you can, on the other hand. Now here's another thing that you can do, right? Is that if in fact we can even do this tonight. If someone has some perfume, some rose perfume, whatever, focus on the sensation of your sense of self, okay, and continuously associate that with the rose smell. You can do it with your cologne. You have to do this kind of repetitively. And eventually, when you start to feel and think of your sense of smell, automatically the smell is triggered. Now, the key thing here is, do you want to replace that original sensation of your sense of self with a smell? So it's sort of a non-answer, but it could be either or. In my case, it was more the feeling of the smell. Just like right now, there's my current feeling of my sense of self, or the feeling of saying these words, but it's not necessarily the words in and of themselves. I'm just saying this in English. I could say it in different ways. But the last thing I did want to leave everybody with is, actually I think I wanted to leave them with two questions. All right, two questions, and then we'll wrap it up because I'm rambling on. So the first question is back to the idea of the unknown unknowns, the blind spots that we don't even know that we have. Let's just say you are, you're an archaic older human before modern technology, or you're a human that's born whatever, and someone just plants you somewhere in a forest, right? More of a thought experiment, but what if you never saw the concept? You never saw a fire or smoke or anything like that. How would you be able to look at the informational properties, the perception of those sticks and those rocks, and think of creating something like fire? How do you create true novelty, something that you haven't even thought of before, right? How do you tap into that? And it's this very difficult thing, because we talk a lot about originality and novelty, and what happens a lot of times, we'll end up combining different things together. But is there a way to originate that without doing that, getting it something more pure and unadulterated? And then the last thought experiment. Yes, I know what I'm doing with keeping up the time. Sorry, but the last thought experiment is, let's just say that you had a problem for someone that, let's say they had an IQ of maybe 200 people, okay? And I know that's not how the IQ scale kind of works, it's a little complicated, but let's just say you have a very difficult problem for someone with an IQ maybe 200 to solve, okay? Now, why is it that you can't have two human minds together, each, an IQ of 100? Why can't they work and communicate and coordinate with each other to solve the 200 IQ problem? Because if you try that right now, you probably won't be able to do it. The language is not able to communicate that, like the different areas of your brain are able to communicate whatever to do this. Because there's something about keeping it all, compressed and coherent in one structure together in real time. And one of the things that I'm very interested in working on is this kind of hyper language, whatever, that lets you take advantage of more deeper cognitive properties. We can talk about that offline. But just to wrap things up now and say thank you to everybody who gave me more than the allocated time to speak, because I know these things can go on forever. Obviously very generous. Augmentation Lab is an incredible organization. Dunya, everybody's done a fantastic job. Let's give it up for Dr. Hahn. Let's give it up for Dunya. Clap. Please clap. And yeah, you'll...
And Addy.
Yes.
Okay, thank you so much, everyone. Also, everyone online, we're glad that you joined us. Please give us feedback, like if you have ideas in the Discord, how to change this, how to make it better, let us know. Thank you so much again. I'll see you, Addy. I think we'll wrap it up here for everyone in person. We got waffles.